Hi guys, this is the concept of a rolling motion. To understand properly what is rolling motion, first we need to understand what is translatory motion and what is rotational motion. So basically translatory motion means each and every point of a body should have the same velocity as a center of mass. Means if you look at this first diagram, this is one solid sphere and it's sliding on the smooth surface. So if it is sliding on the smooth surface, so if you look at the velocity of a C, that is center of mass, this velocity is V. It means if it is translatory motion, velocity of this one should be V, this one should be V, this one should be V. Means all point, each and every point of this body should have a same velocity as a center of mass. So if we see center of mass velocity is V, it means each and every point velocity is V only. Now this is concept of a translatory motion. Now if I explain a little bit more what is translatory motion, let's say I draw one line from R to P, this line R to P, and if this line throughout the motion remain vertical, means if I slide this sphere को right side slide करते जाएंगे या left side slide करते जाएंगे, and if this line will remain straight vertical, means along y axis only, it means what? Each and every point have the same velocity. Sphere is not rotating. So sphere is not rotating means this one is translatory motion. Translatory motion is simple. Once again I am repeating, each and every point should have a same velocity. Same velocity means you already know mechanics. Same velocity means speed should be equal and as well as direction should be same. Now what is rotational motion? Rotational motion means, if you look at second diagram, this one, rotational motion means each point have a different linear velocity. For example, if you see this point A have a linear velocity r omega, point S have a linear velocity r omega, point P have a linear velocity r omega, this point have a linear velocity r omega. If you see their velocity magnitude will be equal, but directions are different. This direction is right side, this one down, and this one left side, this one, and center velocity is 0. It means rotational motion defined as center velocity should be 0 and rest of the point should have a different linear velocity. Of course, angular velocity will be equal. Angular velocity in this case I am taking omega. So omega will be equal, but r omega will be different one. Why r omega will be different one? Because of direction. Their magnitude will be equal, but that r omega will be different one. So two things I defined, guys. First is translatory motion and second is rotational motion. Translatory means each and every point should have the same velocity as a center of mass. Rotational motion means each and every point should have a different linear velocity except center of mass. Center of mass velocity should be 0. That center velocity should be 0. Now these two are definition for translatory motion and rotational motion. Now combination of these two, if I take combination of this one, these two motion, translatory and rotational, we say this motion is rolling motion. So I'll explain a little bit what's a condition for rolling, because every translatory and rotational not necessarily it's a rolling motion. There must be some condition. What's a condition? That I'll explain. Now combination I'll take first diagram and second diagram, I'll merge over here and I'll make collective diagram over here. Means what I did, this first diagram, this second diagram, I merge over here. And now I need to define what is rolling motion, because every combination of translatory and rotational motion is not necessarily it's a rolling motion. Now if you see this diagram, this one, velocity of this r will be v plus r omega. That will be v plus r omega. Why? Because v because of this translatory motion and r omega because of rotational motion. Similarly, velocity of this one v because of translatory and r omega because of rotational motion. Similarly, for point P, v because of translatory motion and r omega because of rotational motion. So what I did, basically this first diagram and second diagram I put together, I merged it. Now in this one there are velocity due to translatory motion as well as rotational motion. Now if you see this point P is called point of contact, that will be on the surface. So this point of contact will have with two velocity, v because of translatory motion right side and r omega because of rotational motion, that will be left side. So what is basic condition and what is important condition for rolling, that point P should be an instantaneous rest. So remember guys, what I am telling, this point P should be at instantaneous rest, means it is not at rest for every time, it is at rest for a fraction of second or else for very small time, a small fraction of time. So that will be at instantaneous rest. It means this point is not sliding on the surface. So if this point is not sliding on the surface, point P, I am talking about point P, it means right side velocity should be equal to left side velocity. So in short, we can say this is the condition for rolling. What is condition for rolling? V equal to r omega. And this condition I derive from that point only, that point P should be at instantaneous rest. So what is rolling motion? It's a combination of translatory and rotational motion if point of contact of the body is at instantaneous rest. This point of contact should be at instantaneous rest. It's written over here. So again, if I redraw this diagram, I'll get this one. In this diagram, if you see, if it is a rolling motion, so obviously V should be equal to r omega, and if V is equal to r omega, so wherever V is there, that will remain V, and wherever r omega is there, this one, this, I'll write V. So every place I'll write V and V, wherever r omega is there, I replace this r omega by V. So I'll get this diagram. So this is rolling, and if you see point of contact P, velocity will be 0. So if r omega I replace by V, I'll make another diagram. This one is fifth diagram. So if you see this V plus V, V plus r omega, and r omega is equal to V, it means V plus V, that become 2V. But here V right side and here V down. So this V and V, if I take vector addition guys, that will become root 2V. It won't become 2V, it become root 2V. So this velocity of this point P, that will be 0. Here also this V will be right side and this V will be up. So resultant of these two, that will be root 2V, and center of mass velocity will be C. So this is complete diagram for pure rolling motion. It means if I ask what's the velocity of point P for pure rolling, of course it's a main condition that point P, that contact point should be at instantaneous rest. It means point P velocity will be 0. Now if I ask what's the velocity of point Q, so that will be combination of V and V, vector addition of V and V, and if you see angle between these two, 90 degrees. If I take vector addition of 92 degree angle vector, in that case that will become root 2V. So velocity of point P, that is V, velocity of point Q, that will become root 2V, and if you see the direction of this one, that will be northeast. So I am writing one unit vector along that northeast. Now if I ask about point R, that will become 2V. See, velocity V and V, they are in the same direction, so simply by vector addition only I am adding, but that become 2V. V and V in same direction, if I add by vector also, that will become 2V. So if you see that point R, that will be 2V. Same logic for point S. For point S, V right side and V downwards. So addition of these two become root 2V if I take vector addition. So that will be root 2V, and direction will be between these two. So this is unit vector for that direction, and center velocity, that won't be 0. Center velocity will be V. Velocity of that center, that will be V.